Welcome, everybody. We're just waiting a few more seconds for attendees to join, but you're at the right place if you want to hear about the experience of high school students. All right, it looks like we might be good to start. So welcome everyone to our last panel of this 3 days CubeSat Developers Workshop. And this panel will be on career and technical education mission. We are very much excited to have our panelists who are high school students. So thank you very much for joining us today. You're going to inspire the next generation of high school students, no pressure. And I would like to introduce the moderator for this panel, Albert Palacios. Albert Palacios is in the Division of Academic and Technical Education at the US Department of Education and lead the Adbere's portfolio of open innovation challenges, including the CTE Mission CubeSat Challenge. Albert's work focuses on increasing access to innovative technologies and emerging career pathways in career and technical education. Albert, the floor is yours.
Thank you very much, and I'm both honored and humbled to be joining this workshop with the students from the 5 finalists in high schools in our CTE Mission CubeSat Challenge. We embarked on this challenge a couple of years ago, and then when COVID hit, we had to kind of recalibrate, and we launched our challenge in August. And by December, we were able to announce finalists that would receive the CubeSat kits and a small cash prize to help them with their project. The background and information can be found on edprizes.com. You'll find the CubeSat, the CT Mission CubeSat link there. It's also ctmissioncubesatchallenge.com. So I wanted to start by introducing have the students introduce themselves. As Pauline mentioned, I'm with the U.S. Department of Education, and I work in these areas, STEM, cyber, tech, space. And I try to get more innovation programs into high schools to try to get that seed planted earlier in all students' minds that they are capable and of achieving some really good things, not just in high school, but in preparing for both post-secondary education and in the workforce. So let's start. If each student, as I go around, can tell us about what school you're from, what year you are in your school, and then a little bit about your CubeSat mission. What's your kind of 30-second description of your CubeSat? So we'll start in alpha order by high school. So let's start with Matthew.
Hi everyone, my name is Matthew Keshishian. I'm a junior 11th grader at Clark Magna High School, and our mission is to use our CubeSat to get information about the location of homeless encampments in our area that are near high fire risk zones and provide that information to local fire authorities to relocate them to a safer location for them.
Great, and from Freeport High School in New York, Victor?
Hello, my name is Victor Villatoro. I'm a sophomore at Freeport High School. The mission for the Freeport CubeSat team is to collect data for the urban heat island effect. The urban heat island effect is, generally, urban areas are warmer than rural areas, even though they receive the same amount of sunlight. Using infrared cameras, we will be able to collect data and compare the differences.
Great, and Mooresville High School, Joseph.
Hi, I'm Joseph Attanucci, and I'm from Mooresville, North Carolina. We're using our CubeSat to measure the effect of our town's population growth on factors such as air quality, land use, deforestation, and temperature.
And I just want to make sure I'm pronouncing it Opelika. Is that good? Thumbs up. Got it right? All right. Opelika High School in Alabama, who partnered with Northside High School. Tilahta?
Hello, I'm Tilahta Adbere from the Northside Columbus and Opelika High School Alliance, and I'm a senior. Our goal for our CubeSat was to essentially build a custom magnetometer that could prove that met glass cores were a viable replacement for the original cores that NASA used in their own magnetometer.
Great. And last is, but not least, is Suhani from Princeton High School in New Jersey.
Thank you so much. I was a little bit late due to technical issues. Could you please repeat the question for me?
Sure. Just give us, just introduce yourself. Tell us what year you are in school, and then also the mission of your CubeSat.
Okay, I'm from Montgomery High School from New Jersey. I am a sophomore currently, and the goal of our team was to use the XK90 in the most variety of ways and to be able to explore the most branches of science through engineering. So we had 4 sub-missions to accomplish that, and they dove into various fields such as physics and astrobiology.
Great. Well, thanks a lot. And you can imagine that, I mean, I can imagine that this was a very ambitious project to embark on, especially during the pandemic. I mean, the pandemic added an additional layer of complexity for this, on top of, I don't know where you all were in kind of your understanding of CubeSats, but what made you and your school join in and get excited about joining the CubeSat challenge? We'll start with, how about Victor?
Well, our district has always had a very big population of students that are interested in science and computers, and we have a majority. We have a variety of CTE courses, and when you enroll students in CTE classes, they gain interest in the science field and the technology field, and the CubeSat was a great opportunity to put Freeport on the map, and that appealed to a lot of students and pushed for the administrators to get us into this mission. And Scott Tingle was also another big influence for the district. We had while Scott Tingle was on the International Space Station, we had a call, and there were a lot of people. This was 2 years ago, I believe, and there was a lot of people, and that awoke a big interest in a lot of students. Hearing that voice from someone who's in outer space. And we had another Zoom meeting when he returned a few months ago. We had another meeting with him, and that only grew the interest of many people.
Great, that's great to hear. And for those in the audience who aren't familiar with CTE, that's Career and Technical Education. These are programs that usually started around the 9th grade and go through high school and into post-secondary education. They teach academic, technical, and employability skills to students in high school and prepare them for both career and college. Suhani, can you elaborate a little bit more on your role in the mission, kind of what you did and kind of what you learned during your experience?
So the way our mission worked was that we were split up into 2 different teams. So the Princeton High School was focused more on the 3D printing aspect of it, whereas our school was focused more on the software aspect of it. And my role specifically was very much focused on software and getting the code to work and getting data collection to work. And one thing we learned from this project was the significance of communication, especially through due to COVID. We were forced to use various methods of communication, and it was something that I know that I learned, and I'm sure the rest of my team learned as well.
Great, and Joseph, you, I think in your project, I think, what sort of skills did you develop, and how do you see it kind of translating to where you're going in the future?
So skills and specifically that we've learned, especially all of our team members, we've learned how to use Autodesk Inventor, to design our 3D model, which we can take outside of high school into possible career paths in manufacturing and other things. And then also software, so with X-in-a-Box chips and learning coding in general to grow our abilities, not just for the CubeSat, but again, for outside of high school and computer science.
And what are your plans after high school, Joseph?
I plan to pursue a degree in construction science and do something in architecture or construction management after college.
And kind of where did you see that kind of background and that area of interest playing into your kind of participation in the challenge?
So engineering as a whole really helps with what I'm interested in. And then just this project was an opportunity to grow that. And I think a lot of the other members also agreed that for their career paths.
Great. And Tilahta, I actually watched your live stream of your launch last week. And what did you what was your role and kind of what were you thinking when it came time to actually get your CubeSat off the ground?
So the process with that was very interesting because everybody on the team had absolutely no idea what we were doing when we started off. This project was very new experience for everyone, and there's a bit of a learning curve before we're able to get that off the ground in regards to both the physical structure of it, which our Opelika sector took care of, and then the actual electrical and the circuit stuff, which we, the Northside and Columbus sector, took care of. But when that balloon finally took off, it was just so incredible to see all the work that we put into this physically come to fruition.
And so Columbus, from what I understand, was it Northside High School or other schools in Columbus, Georgia, had already done projects like this and had some experience? Were they able to mentor you through the process?
We were fortunate enough to have actually our main mentor, Mr. Richardson. He had some experience with CubeSats in the past, and he had already, with the previous group of students, submitted a proposal that was beaten by the likes of NASA, but it was also a finals proposal. No, not NASA, MIT, I'm sorry. But then we also got help from Mr. Keith Warren, who's an electrical engineer, and he essentially walked us through the process of making our own custom magnetometer circuit. And though we weren't able to fly the actual circuit on the balloon because we were still working out the kinks and making it even better, we were able to fly a solid state magnetometer on there, of which we actually knew how it worked. So the knowledge was still there, even if the physical aspect wasn't.
So, and I'm sure just as you had to, you said you had to tweak it before you could launch, and you couldn't launch the one you really wanted. You probably had to make a lot of changes along the way and kind of tackle unexpected instances, which is true in design and engineering of any kind of complex project. But so I have a question. How were you able to retrieve your CubeSat after it landed?
Unfortunately, not.
So where did it land?
We were able to triangulate to position somewhere in the Buena Vista area where some of our mentors were able to do some calculations and pinpoint within a half-mile radius where it could be. And we're planning on getting it on Saturday because we were able to pinpoint the location pretty specifically, and we're gathering the resources and personnel to go over to that area and do a little hunt.
Mm-hmm. Was it on another installation or something, or?
At first, we thought that it was on the Fort Benning installation. after some more careful calculations, multiple calculations, that they actually align together, 3 different calculations. So we're pretty certain that we know where it is. It's just a matter of actually retrieving it.
Oh, cool. Well, that's good. I hope you're able to get it back. I was watching the video, some of the videos from its landing. So yeah, it's literally a needle in, well, it's not literally, it's figuratively a needle in a haystack. So Matthew, can you tell me a little bit more about kind of where you started at the beginning of this challenge and kind of what you were able to learn and develop and kind of what you're going to carry forward from this experience?
So our team started this project with pretty much no knowledge of the CubeSat competition besides our teacher, Ms. Evans-Bai. And we kind of got a lot of help from our community in working through this project by consulting with community professionals in both 3D printing as well as software development in our area, and we also were able to get into contact with the Arduino co-founder. So using that mentorship experience, we were able to develop skills in 3D modeling, software engineering, and also cooperative teamwork. And we used that teamwork to split our project into little modules, kind of like the X in a box can be. And we had our X in a box assembled separately by different people to overcome the communication challenge presented by COVID. So once all those parts were ready, then we could kind of bring them together and assemble it into the CubeSat. And my job was to get the software working with all those different parts. And we went through a really iterative process with our CubeSat because we went through several different designs and using different hardware until we finally came to our final model. And honestly, the skill that I learned the most from this is that you always have to have a backup plan to whatever you're doing, because without our spare resources and having other options when it came to our hardware, especially our IR cameras, there was no way we would have been able to fly because there were so many problems that we faced on the way that we were only able to solve with other alternatives. And for the future, I'm looking to go into software development, and the skills I learned working with Arduino and the IDE that comes with it are very useful, especially with the C# language, and I'm looking to take that forward.
Great, great. So it sounds like it. I think all of you were able to kind of gain some skills from this that maybe you didn't have before, exercise some skills that really interest you. But were there anything that you learned in this entire experience that completely surprised you? Like you weren't expecting to get this when you started. So let me start. I'll start with Victor.
Well, something I learned that was very unexpected was how many times you're going to fail before you get it right. It's just unbelievable that you try and try again. You try one way, you try the other, and it just doesn't work. But eventually, through perseverance, you learn and you find a way to get it done. And I think that's something big that the Freeport CubeSat team has learned: perseverance. Apart from learning about how many more areas and opportunities there are in the STEM fields, we learned a life lesson: perseverance.
Yeah, and I'm sure you'll find that that's an important lesson to learn as you continue both your education and your professional careers. What about you, Tilahta? What was something surprising that you that surprised you in this process?
How multifaceted this field is. Just a small box took so many different elements, so many different people, so many different skills, not even to get it to fly, just to get it to a comfortable point where we could say this can fly, let alone the additional mentorship and the additional skills needed to actually fly it. Just shows that it's not a standalone field, and that there's a place for everyone who wants to try and get into this.
Great, well said. And Suhani, what was something that surprised you in this process?
Something that surprised me during this process was how much I learned about the significance of teamwork, because a lot of us were experienced in very selective fields. So I know a lot of people in Princeton, for example, had a background in 3D printing, but not in software. In terms of, like, for example, for me, I had some experience in software, but nothing at all in hardware. But working together and getting the correct resources, we were all able to work as a team, as a collective, to come up with something greater than the sum of its parts. And I think that's really fascinating, and it's a lesson that we all learned.
Great. And we'll go to Joseph. What's your surprise that you encountered through this experience?
I think the biggest thing for me and my team in particular was how much planning you need to do. We had to plan for every possible scenario, for the launch, for printing our cube if the printer malfunctioned, or if our chips wouldn't communicate with each other. And we just had to plan for every single little detail, no matter how likely they were to occur. We just had to have a big master plan for every aspect of our project.
Great. And Matthew, what's your surprise takeaway from this project?
What surprised me the most from this project was how much more you can learn from person-to-person interaction rather than just the internet, because as I said, my job was software development, and with the Arduino, I was looking everywhere on the internet, trying to find information, trying to find fixes to my problems, and anything that I wasn't able to find online, I was always able to get in touch with a mentor and work through it with them. So even though in the past I've always thought that the internet was the number one resource, it's also very important to have people that you could actually talk to that have experience in that field, and that was my biggest surprise.
Great. And I'm glad through some of our sponsorships of this challenge, we were able to bring some of those mentors like Arduino and X in the Box to your school virtually. So speaking of virtually, and we'll stay with you, Matthew. So fast forward to the fall, or a couple of years down the road, there are a lot of educators in the audience. What would you tell educators about, like what would be key to having a successful program like this in like continue in your high school?
I think that the most important part of this process, that was really what kept all of our team members motivated, was the hands-on involvement you get with projects such as this, that you don't get from like finishing a worksheet, for example. That it's the involvement that students have and the sense of accomplishment they get from seeing the fruit of their labor. That's what makes CTE programs like this so successful, and also keeps the high level of student involvement. So if you're an educator looking to create a course like this, then the number one thing you need to look out for is to keep student involvement high and make sure that they could actually see the rewards of their efforts.
Great. And Suhani, if you kind of looking at that, getting more students involved, opening access to more students to these to programs like this, what would you tell the educators in the audience about what does it take to get more students in?
I think this program is wonderful, and I love what Matthew said about the significance of it being hands-on and being able to see your efforts pay off. I think one thing that could be a little bit more improved is making it a little like CTE is about as a concept. I remember when I was introduced to do a little bit more digging. I think maybe if that
You're breaking up. I think you have a bit of a bandwidth constraint, but if I understood you correctly, it was to better understand kind of what the CTE model is all about and how it works, and to hopefully through that would kind of interest more students and give more students access to creative programs. I mean, and Victor, you were you have taken a few CTE courses, and I know that your background, I mean, the range of career and technical education courses that you've taken are pretty broad. I mean, the range is pretty broad. Kind of how do you, what do you think CTE or career and technical education classes and programs bring to not just this opportunity, not just to the CubeSat opportunity, but to all the other opportunities and experiences that you've had?
Well, I'm guessing the question is, how do CTE classes apply to past experiences?
Well, what did you draw from them?
Well, I realized that there is so much more to computers and technology than what people see and use in their everyday lives. People might look at anything and they don't know the work that falls behind all the CTE courses, what people have to learn and go through to be able to build and design those things. Anything from a computer monitor to a calculator, it takes so much time and effort for people to build those things and program them to run the way we use them every day. And most people don't even take that into consideration.
Thanks. I think once you start to understand that, and it's kind of that constructivist to kind of approach to figure out, how do you build things, how do you make things, what goes into the into everything that we kind of handle and deal with and use every day. There's a lot of people and a lot of skills behind that. Tilahta, how do you what would be your advice to educators in the audience about how to attract a broader range of students to not just career and technical education, but some of these more innovative fields?
One of the things I think would make it more attractive to students is, for one, just to have it open, because a lot of the things that I feel about the lack of turnout is that a lot of students simply don't know about the opportunities that they have in their schools. Because at Northside, for one, we do have a good CTE program, but one of the flaws is that a lot of the programs or information that's given out is kind of kept secluded to just the magnet program and not a lot of the other students. And there are a lot of students there that are interested in things like robotics or like just engineering type courses, but they just don't know about them, so they never get involved. So just to do things like that. But to show the students the results, as Victor was saying before, just to let the students know what that translates into, the things that they use, the fact that they can figure out that so much work goes into just a simple smartphone, so many calculations, so much work goes into that, and then they think about those courses differently. Think about how maybe I could do that next big thing if only I knew how to do that.
Well said. And Joseph, kind of what do you see as kind of some of the important aspects and I guess like would be on your wish list of programs like this, like moving forward? What would you love to be able to see in your schools?
I think the key to our CTE program for any school is student involvement and making sure that the students are guiding it with teachers, of course, with teachers helping, but letting the students choose the direction they want to go in, as long as it aligns to the curriculum or whatever's trying to be taught. So if you could if you could assign a project to a student, let them go in the direction that they want to, as long as it meets the guidelines and everything that particular project is based on.
So did you experience some of that in this experience project?
Yes, our teachers were very good in this project. They left all the major decisions up to us. Our purpose of the mission, designing of our CubeSats, how the software, they were really just there to assist us and guide us and keep us in the right direction. But the students were the ones who were really making all the big decisions.
And we'll go to you, Suhani. What would your moving forward? So you've built this prototype, and what's next for you and the prototype? Like what's your school going to do with the prototype? What are you planning to do in this field of CubeSats? Do you want to maybe build your own? Do you want to pursue, what kind of career pathways do you think you're going to be pursuing?
Personally, I think aerospace is a really interesting field, and if I could get into aerospace engineering, that's something that I really want to do. That's a part of the reason that I found this program so interesting, because it was such a hands-on way to get an exposure to that field. In terms of what we're going to do with the CubeSat in our school, I wouldn't be surprised if we ended up continuing to work on it as a part of our ThinSat club and using it further and maybe testing it more and things of that nature.
So what's your dream job, Suhani?
I don't really have a dream job yet. I just have a field. I haven't really narrowed it down to like a specific career yet.
What about you, Tilahta? What's your dream job or career or destination?
Fortunately, I've been accepted into the Georgia Institute of Technology with the major of aerospace engineering. So this is very pertinent to what I'll be studying in the future.
Great. And, I was talking to a post-secondary a university educator who was kind of surprised in their CubeSat program when some of the students didn't understand how to solder or didn't understand about basic circuitry. But it sounds like through this, you'll already have that foundation going into a program like that.
Mm-hmm.
And Victor, what's your dream job? Where do you want to go? What do you want to do?
I want to be an aerospace engineer and develop technology that will get us to Mars.
Cool. And do you have what I understand you have a current internship coming up? Do you have an internship or something coming up?
Yes. Oh, for the summer. So
Yeah.
for the summer, the Freeport district will be doing a CubeSat kind of workshop for the students to gain interest from the younger group of students coming in, because I'm a sophomore and we have several seniors working on the team. So we need the young people coming in. We need to grow that interest within them. So we'll be hosting a summer course, a summer workshop for those people coming in, and anyone else that wants to join and be part of this team.
That's great. That's great to hear. You're kind of planting the seeds for the next cohort of students coming in. And Joseph, what's your dream job? Not just like what's your major, but what's your dream job?
I'm not sure exactly on a dream job per se. Something that I could improve low-income housing has been an interest to me. So something that we could make efficient homes, energy efficient, and then efficient financially for the general public. That's an interest for me. So something in that field.
That's great to hear. I've seen some of the advancements in low cost housing, the manufacturing of low cost housing, or low cost manufacturing of housing, and so the advances that are being made to make them both energy efficient and efficient to build are really impressive. How it's been advancing over the past few years. And Matthew, what about you? What's your dream job?
So my dream job is actually two jobs, and one is to be a cybersecurity technician as like the source of main income. And also I want to do software development on my own, as in create stuff that interests me and I feel like would be useful, but doesn't necessarily have to make money. So I actually was really interested that there was a cybersecurity presentation on Tuesday in relation to the CubeSat, and he actually brought up some very good points, because these satellites, they have the potential to be very dangerous if they fall into the wrong hands, especially the remotely piloted ones. So cybersecurity will be very important for that.
And actually, that's another area that in which I work with the U.S. Department of Education and other federal agencies. So that's definitely a high demand career field. So I'm sure you'll be well positioned to find employment in that direction. I'm going to check in with our hosts and do a time check real quick, see where we are. We're well over, aren't we?
You're 4 minutes over, but you're also the last of the day. So if you want to do a last, like, final words type of thing, I mean, go for it.
Well, do we have the ability to get questions from the audience, if any?
Yeah, of course, we can ask. So for the audience, you should see a Q&A button at the bottom of your Zoom screen. So if you'd like to submit question there, and we can wait a few seconds to see if there are some coming.
So I'll answer the question before it gets there. No, we don't have plans to do another one. That's the first question I'm usually asked. Unfortunately, this was a single project, and it took years to kind of get to this point. I'm not closing the door on future competitions, but we wanted to get it to this point, kind of see what lessons we learned through this process, and then figure out how can we do projects like this more often and better in the future. So so we don't have anything on the books yet or planned yet, but I think this experience has shown us at the department that we can excite a lot of students and invigorate a lot of educators in pursuing some of the emerging areas of emerging technologies by doing these types of competitions.
So we have a few questions coming up. First question is, will the students be writing final reports that will be posted on the CTE website?
Yes. So as a result, so this was flight week, just ended yesterday, and all the 5 finalists did their launches, their flights, and I'll let them kind of describe their flight experience, their flight events. And they at the conclusion of that, all of the finalists will submit a final flight report that will include the lessons learned, the and all summarize their entire build process and their experience with this. So we will be sharing those online, and we hope other educators will find those and learn more about how to integrate CubeSat development into their high schools.
All right.
Oh, great. Hey, Ted. Glad to see you're joined. Yeah, the Michael Galvin question. Yeah, so can you, each of you, maybe in like 15, 20 seconds, say how you launched your satellite? So we'll start with Joseph.
So we conducted our launch at our football stadium. We have a large community around our high school campus, and we conducted it with a drone. So we used our CubeSat as well as a camera with our drone.
And what altitude, what was the highest altitude you were able to get?
We reached around 395 feet. That was within FAA regulations.
Mm-hmm. Great. And those regulations will be, you'll be well versed in those soon, the more you pursue CubeSats. What about Suhani? How did your team launch your satellite?
We had a high altitude balloon launch, and we did it at like an airport type place. And it went pretty well. In terms of highest altitude, I don't remember it off the top of my head, but we didn't get it back. So after we just put it on the balloon, and we had like a machine on there. So as soon as it reached a certain altitude, it would disconnect the satellite from the balloon, so it doesn't go above like FAA regulations.
Cool. Matthew, what was your launch like?
So our launch, we also used the balloon, but we actually needed to recover it because we plan to use the CubeSat in the future. So what we did is we got a very long length spool that we used to actually hand fly the balloon. And for this, we had to check the wind conditions beforehand and start from a spot in the Hansen Dam, which is where there's a huge concentration of homeless people in our area that also is near a high fire risk area. And we chose a place that the wind would actually take the balloon over the entirety of Hansen Dam, and for that we would be able to get pretty accurate data without losing our CubeSat. And we also flew a maximum of 120 feet because the field of view of our thermal camera wasn't able to go beyond that.
Great, good. That's good information. Victor, what about yours?
Well, our launch was held on our football field, and we attached it to a drone, and we went up to a maximum altitude of 200 feet because we are very near to an airport.
Mm-hmm. And actually, I think I caught your the news report on your flight, Victor, on the news. I think it was ABC7.
Yes, it was on ABC. It was on NBC and News 12.
Yeah, cool. And Tilahta, I saw your live stream, and tell us about your flight.
So like Suhani, we also had a high altitude balloon that we used to launch our CubeSat because we already had a DREAMS program, which is doing research at extreme altitudes by motivated students. So we already had the infrastructure to be able to launch it. We were looking at the winds around a week beforehand so that we knew where we would launch, and we launched a balloon at an elementary school in Alabama, and it flew back down to Georgia, where we were able to recover the balloon, but unfortunately not the satellite. So we'll be hunting for that on Saturday.
Do you recall the maximum altitude
it
you were
was
able to achieve?
Around 90 to 100,000 feet. Since it was unmanned, we were allowed to have it go up that high.
Cool. And I just want to quickly respond to some of the chat comments. What else would be interesting beyond CubeSats? Like, what would you also like to see? And I'll just open this up to whoever wants to respond. What other areas in space would you like to study or have a program or a project around? Matthew?
So I actually think what Elon Musk is doing with his Starlink satellites, that's a really interesting application for satellites, even though it's not really what we were doing because it doesn't have to do with sensing. I just like the fact that it's a project that brings something that hasn't been accessible in many areas of the world to like basically everywhere, because the way the satellites work is no matter where you are, it'll be able to position your dish to provide you internet. And I think the fact that we're getting this resource that's like part of most people's everyday life to more and more people, that's a great thing.
Great. Let's see, anyone else? Other areas of interest in space technology, space industry? Well, as you can tell, yeah, Tilahta.
maybe focusing more on the energy aspect. One of our goals for our satellite was to put solar panels on it for it to be powered, but unfortunately, we were not able to get to that state due to the state of our magnetometer circuit. But I think maybe having a project that involved taking energy from the sun while in space would be cool. It may still be a satellite, but maybe having the project more focused on generating and maintaining energy could be cool.
Great, and I know the power budget is something, the electrical budget is something that CubeSat developers always have to consider. So I did want to look at or refer to a couple of comments in the chat, and yeah, I actually agree with these comments that it takes more than just the technical aspect. There are also things like accounting, finance, small business development, entrepreneurship, ethics, especially in cybersecurity area. All of these kind of ancillary topics support things like CubeSat development or cybersecurity or construction or whatever your area is going that you decide to go into. All of these are fundamental skills that should apply across the board in software development. Things like intellectual property, liability, all of those things have a role in that. And as you get exposed to more classes and courses in your educational in your education pathway, I think it's important to include those and understand the relevance of each of those topics to your area of interest. Let's see. Yes, Ted. Glad to see Ted Tagami, who's also one of the mentors and advisors on this program, also join. And yes, he says that would make a great lunar project, the energy one. So I'm going to pass that along to some of our colleagues at the Department of Energy and get their brains working as well. So with that, let's see, does anybody have any last words, or how about a word of thanks? I'll let each of you do a quick thanks to whoever you think was key to this program at your local school. Matthew.
All right, so I want to start by thanking both our teacher and mentor, Ms. Evans, and also all the other mentors we worked with, and as well as all the members of my team, because everyone in our class worked really hard on this project, and it really took all of our efforts coming together to get this thing flying. And I was really appreciative that people were putting in their best effort for that. And also I wanted to thank you as well, Albert, for helping set up this event, because I learned so much from it, and I actually found a new interest in terms of Arduinos that I actually might be looking to open a club for that at our school. So it was a great learning experience for me and my teammates, and thank you very much for that.
Great, and thank you for that, and I'm glad you had an opportunity to interact with Massimo Bonzi, the co-creator of Arduino, through this process. I think that was a great add to this to the mentorship in this activity. What about Joseph?
I'd like to thank both of our teacher instructors, Ms. Parkman and Mr. Estes, and then our CTE coordinator, Ms. Blocker, and then of course all of our community mentors who helped us in aspects of coding, manufacturing, design of the CubeSat, and then of course our team members, as well as the Department of Education for funding this program.
Great, thanks. You don't have to mention us. It's all about you and what you can do at the local and community levels. Suhani, who would you like to thank?
Well, I mean, I know you said not to, but I wanted to thank the Department of Education, because it's a really great opportunity that a lot of people don't come by, and it's really awesome that we were able to get this. I'd also like to thank my team, so a lot of the students on the Montgomery side as well as the Princeton side, and Mr. Gargione for helping us out. It wouldn't have been possible without them, and of course, I have to thank
Oh, cut out on that last.
Without him as well as, can you hear me?
Yeah, you cut out on that last. Thank you. Didn't hear you.
I just said I want to thank Mr. Lee, and Mr. Gargione for helping us throughout this, and all the mentors that helped us, in addition to Princeton University, who also helped us a lot along the way.
Great. And Tilahta, who would you like to thank?
So I would like to thank Mrs. Howell and Mr. Rush, both of who are in the attendees tab, for being magnificent mentors. Mrs. Howell being the head of the CTE at Opelika, and Mr. Rush being our helper with the radio and the communication between our CubeSat and our ground station. I'd like to thank Mr. Richardson, who is our lead mentor for the satellite, and Mr. Warren, who is our electrical engineering mentor. I'd like to thank all the students at Opelika, Northside, and Columbus who were able to come together and make this possible. And once again, thank the Department of Education for bringing us this wonderful opportunity, because there are so many people on our team that now have a sense of what they want to do or what the future holds by being a part of this.
And Victor?
I'd like to thank Scott Single first and foremost for really waking up that interest in so many of us. And Dr. Biersack, who was the professor for the 4-week course I took at Brookhaven National Lab. I'd like to thank Mr. C. Americone, who was the kind of the director for the technology aspect of the electronics aspect of the mission. He was in charge of the drones and everything. I'd like to thank Ted Tagami, who I think he's here. I think he has a couple of questions. And I'd like to thank David Cortels. He was definitely a very, very good help.
Great. And I'd like to thank not just all the students who participated, but also the sponsors, Arduino, Blue Origin, Chevron, and Durasat, Lego Education, Magnitude.io, the MIT Media Space Lab, Exploration Initiative, and X in the Box for bringing some resources to this challenge that otherwise wouldn't have been possible without their support. So I really appreciate them providing the gifts to the department to support this project. I also want to thank all of the educators out there, especially not just those that you named and those that you remember, but those that you don't remember over the years, but will contribute to your development as you move forward through your education and educational and professional pathways. And even more importantly are the educators you do remember, those that you name, the ones that you carry with you throughout your life, and thank them for making not just you the people you are, but me the person I am, and all of us, to help us learn and explore and exercise our curiosity and infuse that technical empowerment and creativity that allow us to discover the next big thing. So with that, I'll turn it back over to Pauline, and thank you all for joining our session.
Thank you, Albert, and thank you all the panelists for this very wonderful talks, and your inspiration, I'm sure, is going to impact a lot of other students. So thank you for doing what you're doing, and just keep doing it. That will be my best advice to all of you. And Tilahta, congratulations on Georgia Tech. That's not an easy feast, so that's amazing. Congratulations. So with all that, that concludes our third and final day for this CubeSat Developers Workshop. So thank you all for attending. Exhibits are still on though until 4 p.m. Pacific time. So please go and check on our sponsors, and you can talk a bit more about some of the services they provide in some areas of expertise for a CubeSat development. So feel free to go there and interact with them. But otherwise, thank you all for joining us virtually this year, and hopefully in person next year. We're going to be able to shake hands again and say hi to everybody. But until then, stay safe, take good care of yourselves, and talk to you soon. Bye, everybody.
Thank you.
Thanks. Bye.